The last thing that we're learning in section 2 is multiplying when we're working with scientific notation. You guys have seen scientific notation before, and we'll talk about scientific notation more later on this year. But for right now, we need to remember the meaning of scientific notation before we bother with trying to figure out how to multiply scientific notation. So, what are these values? What is this if I write it in standard form? Standard form would be written out instead of using scientific notation. So what do I have to do here? We don't cry, or if we do, once we're finished, we continue. So scientific notation is a short way of writing very, very large numbers, or very, very small numbers. This says 6.73, that's a times 10 to the 8th power. If I multiply 6.73 times 10 to the 8th power, what happens is I wind up moving the decimal place 8 places to the right. So I wind up with 673. Now I'm moving the decimal place 8 places to the right. So 1, 2, and then when I don't have more numbers, I add zeros. 3, 4, 5, 6, 7, 8. I've moved the decimal place over 1, 2, 3, 4, 5, 6, 7, 8 places to the right. So that number, 6.73 times 10 to the 8th power, is actually 673 what? Million. What about this one? What does that tell me to do? Go the other way. That's right. We're going to move the decimal place 5 places to the left this time. So we have the 2.5. The decimal was here, now I'm going to the left. Over 1, 2, 3, 4, 5. There's my decimal. 0.000025 is that number in scientific notation. The reason for that is, we can look at this now that you understand what a negative exponent does. What does a negative exponent do? What do we do with negative exponents so far in this chapter? Put it under 1. Yeah. So what you have actually is 2.5 over 10 to the 5th power. So that is 2.5 over 10 to the 5th power would be 10 times 10, which is 100 times 10, which is 1,000 times 10, which is 10,000 times 10, which is 100,000. 10, 100, 1,000, 10,000, 100,000. That's 10 to the 5th power. Is 2.5 divided by 100,000 a very large number or a very small number? A very small number. Enter it into your calculator. When you do, you get that. So that's why we wind up moving the decimal to the left with that negative exponent. The math here tells me to put that 10 to the negative 5th in the denominator, and then 2.5 divided by this huge number gives me that result. And the result was I wound up just moving the decimal 5 places to the left. So that was a shortcut that you were taught when you first learned scientific notation, whenever that was, science class or maybe pre-algebra. That was a shortcut. Now that you understand the negative exponents, this is the math that caused that to happen. On this one, 6.73 times 10 to the 8th power, 10 to the 8th power is like 100 million. So what I have is 6.73 times 100 million. And that's why I get 673 million as my answer. So the scientific notation comes from your knowledge now of exponents. So to multiply numbers in scientific notation, we can think of these as like bases and coefficients like we were just doing. Just multiply the numbers, the coefficients, and then add the exponents, because those are like bases. This is 10 to a power, 10 to a power. Those are like bases, so I can add those exponents together. But I got to multiply those coefficients together, and I don't know what 1.13 times 9.98 is, so that means I'm going to reach for my calculator. So I need somebody to tell me what 1.13 times 9.98 is. Yep. So let me go back to point this out to you again. If we have coefficients out front, we can multiply those two numbers together. If we have like bases, then we can add our exponents together. Okay? Now the z here is going to turn into the 10 on the problem that we're trying to do. This is 10 to the, this is 10 to the, just like it was z to the and z to the. Okay? So that means these are like bases, and since this is multiplication, times, 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 this is all multiplication. I can multiply in any order I want. So I can do the 1.13 times 9.98, and by now we've done that. What is it? 11 point, say louder. Thank you. 2774 times 10 to the, and now we add the exponents and we get negative 2. So that times 10 to the negative second power tells me to move my decimal which way? To the left. So my number here actually, if I move that decimal 2 places to the left, is 0.112774. And that's the answer. What about on this one? What should we do first? Multiply the coefficients, 2.56 times 3.34, and what do we get? 8.5504 times 10 to the 27th power. And are we going to write that all out? I really don't want to. That'd be a lot of zeros that I got to write out. We're going to leave it just like this. This is why we use scientific notation. This number is enormous. We would never be able to comprehend this number if we wrote it all out. So we just leave it like this. Scientific notation says the decimal place goes directly after that first digit, and then the exponent tells you how many you would have to move over, either to the left or to the right, to get the actual answer. So on this one over here, to put this back in scientific notation, I would have to write 1.12774 times 10 to the what power? If I move the decimal over 1 this way, then to undo that I have to move the decimal to the left, which means it's going to be a negative. I move the decimal 1 place. So that would be that number in scientific notation. This is my answer in scientific notation over here. The idea is multiply the coefficients together, multiply the like bases together. To do that, you add the exponents. The calculator does scientific notation. Actually, any calculator that's called scientific will do scientific notation. Any graphing calculator will also do scientific notation. So on your calculators, you can use the calculator to find problems like that. The notation that we use when we write down scientific notation is this times 10 to the exponent, or times 10 to the exponent. The calculator doesn't do that. You can write out 1.13 times 10 to the negative 7 power times 9.98 times 10 to the 5th power. And if you did that, you would get, hopefully, that answer. So let's go ahead and do that. Let's type it all out just like we see it. 1.13. Oh, come on. Times 10. And then the exponent button is that one right there. Little caret. To the negative 7 power. But when you do that, you have to press to the right to get out of the exponent. If you don't, then everything will just stay in the exponent the whole time, and your answer will be wrong. Then we got to go times, and I don't see my little dot, times, oh, it's there, and then 9.98, and then times 10 to the 5th, and then hit enter. And there's our answer. It gives us our 1.1 or 0.112774. It gives us the answer in not scientific notation, just like we found over here. We can put it in scientific notation if we want to from there. So now I want to show you how the calculator actually does scientific notation. There's a faster way to do scientific notation on a calculator without having to type in all of these numbers. It's using this button down here. Looks like a double E. That double E is the calculator's representation of scientific notation. It stands for times 10 to the. So we're going to retype this problem, and this time all we have to type in is 1.13 and then hit that double E button, and you'll see a capital E pop up. That capital E is scientific notation in a scientific calculator. Now you type in the exponent. You don't have to type times. You don't have to type exponent button. You just type in -7. So hit the -7. Then times the other one, which was 9.98. Hit the double E button again. That's your times 10 to the, and then just type in the exponent that you see, which was 5. Hit enter, same answer. So scientific notation is easy to use on a calculator if you understand that double E button. You don't have to press times. You don't have to press the exponent anymore. Notice how this thing wrote it out. The 9.98 times 10 to the 5th was written out as 998,000. The calculator will do that sometimes. The calculator will give you the standard form answer instead of the scientific notation answer sometimes. Let's go ahead and do the second problem this way, using the E. So that was 2.56. The double E button. And what was my exponent on that one? 5. And then what do I have to type? Times. I have that number covered up, so what is it? 3.34 E 22. Hit enter. And there you go. 8.5504, and then it says capital E 27. Now there's something I want to point out here. There are two buttons actually that say E on them. There's this one that we need to use, the double E, capital double E. And then there's this E to the X. That is not the one that we want to use. That is a completely different function. It's an exponential function. It's not scientific notation. That's not the one you want to use. There's another little E somewhere around here, and I don't see it right now. And there's also the capital E right here. That is also not the button we want to use. This is just the letter E. Has nothing to do with anything. It is this double E button that we have to use for scientific notation. So just make sure you're keeping that straight. But if you do keep it straight, then you're welcome to use a calculator to do problems like this. And that's all we have for this section.